So here we are going to discuss traveling salesperson problem. Okay, what is traveling salesperson problem? Here is we will be having set of cities. We will be having set of cities. For example, we have 4 cities. He has to start from a city and visit at least all the cities at least once and reach the starting city. Okay, he is the starting from this city and he has to visit all this vertex at least once and reach the starting vertex, that is this particular city. Okay, and this whatever graph we have is a Hamiltonian graph. What is Hamiltonian graph is that each vertex is connected to all the vertexes in the graph. This vertex is also connected to all the vertex in the graph. This vertex is also connected to all the vertex in the graph. This vertex is also connected to all the vertex in the graph like this. So this is called Hamiltonian graph. Okay. So we will be having a graph which is Hamiltonian. Means he can take any path. Either he can say, for example, it is A, city B, city C, and city D. Okay. So he can take A, B, C, D path, or he can take A, C, D, B path, or he can take A, B, C, D path like that. He will be having all the combinations. Okay. For example, if you have n number of cities, if you have how many number of cities, n number of cities, how many possible combinations will be having here is n minus 1 number of possible combinations we will be having, so that the salesperson can take n minus 1 factorial number of possible combinations will be having, so that the salesperson take any of these paths. But the salesperson has to take the path which is having the lowest cost. Okay. So this connections, the from A to B, what is the cost is given here in the graph. Okay. So we will be finding what is the total distance we will be traveling. So we will be finding the path which is having the lowest distance. Okay. And the salesperson has to take the path which is having the lowest distance. Okay. So that is the salesperson problem here. So what is that here? Here we will be considering city 1 as the starting city, and the same city will be the ending city, because he has to start from the start city and end at the same city. Okay. So city 1 will be considered as a starting city, and he will be ending at the same city. And here we have to how many combinations we will be getting, how many number of permutations we will be getting here is n minus 1 factorial number of permutations we will be getting, so that the traveling person can take any of these permutations. Okay. And here for every permutation, what is that we are doing? We are calculating the cost. Okay. Cost of every permutation we are calculating. And we have to find out the permutation which is having the minimum cost. Okay. So finally, what is that we have to do? We have to return the permutation with the minimum cost. Okay. The salesperson should take the path which is having the minimum cost, means minimum distance. Okay. So what type of graph here we have considered? The graph we have considered is Hamiltonian graph. Okay. So what is Hamiltonian graph? That each node is connected to all other nodes, every vertex. Okay. So each node will be connected to every vertex of the graph. Okay. So that is called Hamiltonian graph. So, for example, here we have 5 city students, A, B, C, D, E are the 5 cities, and the distance between the cities also given in the graph. Okay. Now, what is the starting city is A. The starting city is A. The salesperson will be starting from city A. Okay. He can take different paths. What are the different routes he can take? So, he can go to A, B, D, C, E, A. It is one path. So if he is taking this path, what is the total distance he will be traveling is 610. Similarly, if he is taking the path A, C, B, D, E, A, if he is taking this path, what is the distance he will be traveling is 589. Okay. So if he is taking the path A, B, B, C, E, A, okay. What is the distance he will be traveling is 728. So if he is taking the path A, B, C, A, if it is this path, you have to observe that we are starting from vertex A, ending at same vertex. Okay. So what is the distance he will be traveling is 458. Okay. So this salesperson should select a path which is having the lowest distance. Okay. So this here distance is the called cost. So the salesperson has to take the path which is having the lowest cost or lowest distance. So in this particular case, what is the lowest distance is AB, EB, CA is the lowest distance. Like that, we have to find out all the permutations and we have to find out what is the cost of each and every permutation and we have to consider the permutation which is giving the lowest cost. So this is called salesperson problem. Okay. So here we will be discussing. See what is that here we are discussing. Given a set of cities, the distance from every pair of cities. Okay. So the set of cities will be given, and the distance between every pair of cities also given. What is the problem here is the problem is to find out the shortest possible route that visit every city exactly once and return to the starting city. Okay, what is the problem here? We have to find out the shortest path. Okay, so that the agent has to visit every city exactly once and return to the starting city. That is the problem here. See here this graph, students. So consider city 1 as starting and ending. How many number of permutations we will be having? N minus 1 factorial number of permutations we will be having. Then what is that we have to do? We have to calculate the cost of every permutation and keep the track of minimum cost permutation. Okay. And we have to finally return the permutation with the minimum cost. Okay. So that is the problem here. And here, what is that? If you just, I told you know how many number of permutations we'll be having. Here, 4 nodes. So that is 4 minus 1, 3 factorial. Okay, 3 into 2 into 1. Number of permutations we'll be having here. Okay. So if you just see the permutations here, students, these are the permutations and what is the corresponding cost also given. You have to find out what is 1 to 2. What is the distance? 15. No? 15 from 2, 1 to 2 is 10. 10, 2 to 3 is 35. 10 plus 35. Okay. So that is 45. 3 to 4 is 30. So 45 plus 30 is 75. Okay. 4 to 1 is 20. 75 plus 20 is 95. Like that, we will be finding what is the corresponding cost for each and every permutation. And finally, we have to select the permutation which is having the lowest cost. Okay. The salesperson should select a permutation which is having the lowest cost. Okay. So this is the problem, students.